Algebra, guess what? It's your last lesson. Last lesson, Unit 6. For 2020, it's your last lesson of the year. Getting a little sad. It's been a strange year. So, yeah, this kind of stinks. Let's just do it, all right? So let's look at this warm-up. Here are the graphs representing the functions of f and g, given by f of x equals x times the quantity x plus 6, and g of x equals x times the quantity x plus 6 plus 4. Which graph represents each function? Explain how you know. Well, f of x does not have a constant, no c term, so it's going through the origin. Okay, so that I just recognize that. If I distribute that x, I get f of x equals x squared plus 6x. So there's no c term, so it goes through the origin. And then g of x, if I distribute that, I get x squared plus 6x plus 4. So that's the y-intercept right there at 4, 0, 4. And then where does the graph of f meet the x-axis? I already said that. At the origin and -6. Oops. If I take this equation, x times x plus 6, I set each piece equal to 0 and solve for x. So it crosses the x-axis at 0 and -6. Those are the x-intercepts. All right, how would you change the equation y equals x squared so that the vertex of the graph of the new equation is located at the following coordinates and the graph opens as described? I'm going to remind us all what the vertex form is. V of x equals x minus, oh, I should do the a, sorry. A times x minus h quantity squared plus k. So my vertex is h comma k. So if we would change the equation for this first one, I'm going to get x minus h squared plus k. And the a term is positive. So that right there, I'd simplify it though. I don't need the parentheses with a plus 0. Okay, with this next one, I know I have h and k. Oops. Oh, for goodness sakes. H and k. So it's x minus h, quantity squared, plus k, and it opens up. So it needs to be positive out front. And h comma k. So y equals, this one opens down, so I'm going to throw a negative out front. That's all I have to do is throw a negative out there. X minus 7 squared minus 3. Okay, use graphing technology to verify your predictions. Adjust your equations if necessary. I'm going to go open up Desmos and graph these. I will be right back. All right, so I know I've covered up some graph. Oops, I know I've covered up some writing. It's okay though, I'll get to it. So let's just check. If I look at A, the vertex is at 0, 11 and it opens up. Right there, opens up, we're good. Here, I've shifted it to the right 7 units, but not changed the up and down, and it still opens up. So that is at 7. Here, I've still shifted right 7, but down 3 and opening down. So that vertex right there is at over 7, down 3, and I'm opening down. So they all work out. All right, so take a few notes. I'm going to delete this graph and move on to number 3. Number 3 says, Kieran graphed the equation y equals x squared plus 1, and notice the vertex is at 0, 1. He changed the equation to y equals quantity x minus 3 squared plus 1 and saw that the graph shifted 3 units to the right and the vertex is now 3, 1. Next, he graphed the equation y equals x squared plus 2x plus 1, observed that the vertex is at -1, 0, and thought, if I change the squared term x squared to x minus 5 squared, the graph will move 5 units to the right and the vertex will be at 4, 0. Do you agree with Kieran? Explain or show your reasoning. That was a lot of words, wasn't it? So let's try to summarize what Kieran did. So first graphed x squared plus 1, and the vertex was 0, 1. And then graphed x minus 3 squared plus 1, and the vertex was 3, 1. That all makes perfect sense. Okay, no problem. Now, y equals x squared plus 2x plus 1, and the vertex is negative 1, 0. Okay, that's not in vertex form, so I can't even verify that. But if I change it to x minus 5 quantity squared plus 2x plus 1, that is not vertex form. So I cannot assume that this is going to be a 5 to the right shift because we have other stuff going on that's not incorporated to this. Okay, so write that down. I'm going to go and graph these things really quick and I will be right back. All right, I moved everything to a new slide because it got a little crowded. So I went and graphed these two right here. That's a good arrow, right? Y equals x squared plus 2x plus 1 is right here with a vertex of negative 1, 0. And then plugging in a 5 there, my vertex is now, 4, 10. Okay? That's not how, this is not vertex form. All right? What I would need to do to get that into vertex form would be to expand x minus 5 times x minus 5. Okay, x squared. Let's see. Yeah, this isn't even going to be worth it for you guys. You're going to watch me do some math and think, what's she doing? Combine like terms. Oh, that wouldn't be minus 10x. I've got a negative 10x and a positive 2x. That gives me an 8x plus 26. And then I have to take this and put it back into vertex form, which is actually a topic for Algebra 2. Okay, it's called completing the square, so we're not going to do that. But yeah, I can't just put in an x minus 5 into a standard form equation and expect it to work or act like the vertex form. That's just not how it works. That's not supposed to be there. Sorry. All right, so the last little unit, a peanut jumping over a wall. So the student task statement says, Mai is learning to create computer animation by programming. In one part of her animation, she uses a quadratic function to model the path of the main character, an animated peanut, jumping over a wall. Mai uses the equation y equals negative 0.1 times x minus h squared, that'd be x minus h quantity squared, plus k to represent the path of the jump. Y represents the height of the peanut as a function of the horizontal distance it travels, x. On the screen, the base of the wall is located at 22, 0, with the top of the wall at 22, 4.5. The dashed curve in the picture shows the graph of one equation Mai tried where the peanut fails to make it over the wall. What are the values of h and k in this equation? So I'm going to, that right there is the vertex, that's h and k, so I am over 18 up 5. Okay, so that is the value of h and k in this equation. It's the vertex, 18, 5. So the x direction is 18 and 5 in the y direction. Okay, moving on. Starting with Mai's equation, choose values for h and k that will guarantee the peanut stays on the screen but also makes it over the wall. Be prepared to explain your reasoning. Hold on. I needed the actual picture and the equation. So if my peanut is starting right here, I want to use symmetry and I want this to be my vertex. A vertex at 22, 5. Because I know symmetrically that means that if this is, let's see, 2, 4, 6, 8, 10, 11, 2, 4, 6, 8, 10, 11. That's going to be where it ends. So it's going to go up and over. So my vertex needs to be at 22, 5. I'm up here. Sorry, we don't need this. So choose values for each k will guarantee the peanut. Yeah, I think we're done. Y equals negative 0.1, x minus 22 squared plus 5. So that definitely works, but we could also change the value for k to make it go higher, right? So if we think about that, if we move this up, then it will go over. Let's see, if I go there, that means, let's see. It still would be the same. So that's my line of symmetry. And if I'm 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Okay, that's probably too tall, right? But raising your value for, oh, that's a terrible graph, sorry. Raising your value for k, for the y part, would also work. So if that were the equation, I'd have negative 0.1 times x minus h, which is still 18, plus k, which I don't know, I randomly picked 8. I think 7 would work too if we're down here. Okay, so that would also work. So we could either move it in this direction or move it in that direction, and either one gets us the right answer. All right, optional. I don't need to give you guys more extra credit, but if some of you would like to, I will be glad to give you, please do this. Take a screenshot, somehow report it back to me. You can use Desmos if you would like. Take a screenshot, submit it to Google Classroom, or just email it to me. But we'll make this worth a plus 20 homework assignment. If you don't need to do it, please chill. Don't worry about it. But if you would like to, please do. It looked really neat, kind of fun. Desmos would be a great way to see your answers live. But that's it. That's it. Last lesson, last class. Algebra is over for this year. Good work, guys. I'm really proud of you.